Hello and welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to have a discussion on this paper 2 PR paper, and we're going to have a discussion on how you're supposed to approach different questions and topics which can be tested in this particular exam. This is a prediction on how you are supposed to answer different topical questions, and this is gonna prepare you on how to approach the main exam of May-June. If you're new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. In Proflan YouTube channel, we do maths and physics. So if you're going to take physics in A levels, if you're going to take pure math in A levels, consider subscribing so that anytime we shall be uploading more tutorials in the future, you'll be notified. Also, you can share this channel to your friends, encourage them to join so that we can be able to learn together. So this is a prediction of 2 PR, and if you are taking 2P, that is paper 2 physics. Of course, if you have done paper 1, you will have to do paper 2 physics, and this paper is usually out of 70 marks, but I've just pulled together different questions that can enable you to prepare different concepts. Let's go dive in, and so that we can be able to see exactly what you are expected to do in this case. We are told that a tumble dryer is a household device that dries clothes in this case, and we are supposed to answer various questions. And we are told the diagram, we have the squares of materials and we have the cylinder which actually have a rotational motion. So we are supposed to name the device the student could use to measure the force. Force, an instrument or apparatus that can be used to measure force is basically called the force meter or the Newton meter in that particular case. So basically, this is what we are going to write here, and we shall say this is called a Newton meter, or you can be able to say a spring balance in this case, or a spring balance, can be able to say that is the case. Now state the independent variables in this investigation. So remember, what you need to understand now is that you might be asked a question when an experiment is given, and then you are supposed to identify independent and dependent variables, and also you are supposed to identify maybe what we call control variables. So you need to understand that independent variables, you need to understand independent variables is what you are changing, and what you are measuring is called the dependent variable. So in this case, the material of the squares is called the independent variables, and the force experienced is what we call the dependent variable. So we may also be asked to identify control variables. Control variables in an experiment is those variables which can affect the experiment, so you have to keep them constant so that the whatever that we are measuring is not going to be affected. So in this case, the rate at which the rotation is done should be kept constant. The speed of rotation will be maintained. We can also talk about the size of those squares should be maintained, right? All right, all the type of material in that case should be maintained. Use the idea about electrostatic to explain why the squares stick together when after a rotation. Remember, we can be able to charge materials by friction, right? So when it rotates, there is frictional force. The material, the squares rub against each other, and then in that case, charge is transferred. And when charge is transferred, some material will acquire a positive charge and other materials may acquire a negative charge. So those squares which have the same charge, they are going to repel, and those which have opposite charges, they are going to be attracted. So we need to understand that this case that the squares rotate, as the squares rotate, due to friction, charge is going to be transferred, and a material becomes positively charged when it loses electrons, and it becomes negatively charged when it gains electrons. So you need to understand how materials charge. They charge due to frictions, and when charge is transferred, all electrons are transferred, because protons are never transferred, so it's only electrons which are transferred. So explain which type of graph is most appropriate when you are supposed to represent the data or the result of this investigation. So this is another question that you may be asked, and you need to identify, are you having discrete data or are you having continuous data? So if you are having discrete data or non-continuous data, you are going to use bar graphs or bar charts. But if you have continuous data, yeah, you are going to use a graph which we call a line graph. Yeah, so that is what you consider whenever you are supposed to answer that question. So if you are new to Proflan YouTube channel, consider subscribing, and at the same time you need to, if you are new, you can also join our Patreon page, where I usually upload these particular PDFs that I usually do here, so that you can be able to access all that we need. All right, so we need to move further. We need to all right, so we had stopped at this particular question here, where we talked about, now state the formula linking charge, current, and time. We need to remember that the formula, you can be able to work how charge is basically current times time. So what you need to remember at that given point is that charge has to be is calculated in coulombs, and also current should be in amperes, and time must be in seconds. So that is the most important part to remember. So probably a question from charge and can be asked. Also charging materials, how materials are being charged, can be asked. So you need to prepare on such kind of questions. Moving further, we need to move to the next area. The next topic that we're going to have here is a topic to do with transformers. We need to understand how transformer works, and also we need to understand how to do different calculations on transformer. We're told that a mobile phone X contains a transformer and used to charge a phone battery, and we have the specifications there. We have voltage of 230 volts, we have output voltage of 5.0, so you can see voltage is reduced, input is 230, output is 5.0. that is a step down transformer, because the purpose of a transformer is to reduce voltage, and we have the output current should be 1.2 amperes. We are supposed to work out the output power. So we need to understand that power is the current times voltage. So in that case, we are going to say power is current times voltage, and all that is given here. So we shall say this is going to be 6 watts. 6 watts as the final answer. The next part, we're supposed to calculate input current for the charger. But the first aspect that we have to put into consideration is that power input is equals to power output. And this is because we are told this transformer is 100% efficient. So we are going to say the power in is equals to power out, but power in is going to be the current in times the input voltage, and we have gotten the power out from the previous calculation is equivalent to what? Is equivalent to 6. So we are going to say current is equals to 6 divided by, current is going to be 6 divided by 230. And if we can do our calculation here, if we can do our calculation, 6 divided by 230, 6 divided by 230, that becomes 0.02. Yeah, so that becomes 0.026 in that case amperes. And well, we can now move to the next part. And then we are told that charger X transfers a charge of 10,500 coulombs. So you see they are trying to amalgamate the topic of power, transformer, electricity, and then you are bringing in the charge, and they're asking you the formula, which we have already done, but then that be a second part of revision on how to work out that charge is equals to IT. And we can see here we are told in minutes, so we need to use the current there. That was the output. So if we divide by that, we are going to get our answer as 10,500 divided by 1.2, which becomes what? If we work it out, our answer becomes 8750. But since we were asked to work out our answer in minutes, we have to divide by 60 here, so that we can be able to convert to the unit that you are expected. So anytime you are answering questions, you have to ensure that you are giving your final answers as required in the unit that is expected. So it should be 140, so you don't have even to repeat writing the units because they are already written. And then we have charger Y can also be used to charge a mobile phone. The diagram. So we were having charger X, and you can see the different specification. Explain how the time taken to transfer the same amount of charge is going to affect it. But you can see now the power output of this charger is a bit larger, because the output current is higher, is 2.1. The other one was 1.2. So which will mean that this one is going to take a less time to charge this phone, because it will be transferring more current within a very short period of time. So time taken to charge will be less because current is greater, and we have already said charge is current times time. So if current is high, it has to take less time to do the charging. The next part here is where you are supposed to explain how a step down transformer works, and then maybe you are expected to include a diagram, but I need to be very straightforward here. I say when alternating current flows through the primary coil, magnetic fields which are constantly changing size and direction are created in the primary coil, and when these magnetic fields which are created cut across the secondary coil, an EMF is going to be induced. So the changing magnetic fields cut across through the secondary coil, and an alternating current is going to be induced in the secondary coil, and that's what's going to happen. And now the most important aspect that you have to remember is transformers works with alternating current. They cannot work with steady direct current, because direct current don't create magnetic field which are constantly changing size and direction. Yeah, so if you are asked to state how a transformer works, be very straightforward and say when alternating current flows through the primary coil, they create magnetic fields which are constantly changing size and direction. When these magnetic fields which are constantly changing size and direction cut through the secondary coil, an EMF is induced in the secondary coil through electromagnetic induction, and then the examiner will be very happy with you. You'll be getting your marks when you state your points as precise as possible. And then that is exactly what we are going to say. And since there are fewer turns in the secondary coil than the primary coil, then we're going to have less EMF induced in the secondary coil, and that is why now it works as a step down transformer. Less voltage is going to be produced. Moving down, we are to describe an investigation to determine the speed of sound. Now, there are different ways you can be able to determine speed of sound. One way is to use echo method. Echo method is where two people are going to stand 50 meters away from the wall, and in that case one person will be having pieces of wood to be banged together, and the other person will be having a stopwatch. The person with the stopwatch will start the stopwatch immediately the person produces the sound, and then stops the stopwatch when he or she hears the sound. So this guy here who is having a stopwatch, this guy is going to stop the stopwatch immediately. The sound is going to travel to the wall and coming back. So sound will travel from the two guys there. It will travel to the wall, and then the echo will be added after that sound has been reflected. So that is what we're going to do, and the standard distance in this case is going to be 50 meters. Now that sound is produced, it will travel to the wall and then it will come back. So we're going to say two students should stand 50 meters away, and this distance they are going to stand 50 meters is going to be measured by a tape measure. So whenever you are going to describe physics experiment, you must include the apparatus of an instrument, that the apparatus and the instrument you are using, and at the same time you have to ensure that you are stating how you are going to achieve accurate results in that case. So of course, ensuring that your time is measured accurately, distance is measured accurately, but most importantly, you are going to perform repeats so that you can be able to have the result well done. So this is echo method we're going to use at this given point, and we are going to say here that we're going to say that one student should bang the two pieces of wood together, and the other student is going to start immediately the pieces have been banged together, and then stop the stopwatch immediately they hear the echo, right? And then so this they are going to repeat. For this case, they are going to repeat and then find the average time which the sound takes to travel to the wall and back to them. Then we are going to apply now the formula for speed. Speed of sound is going to be 2 times the distance from the point where they are to the wall over the average time that has been obtained. So the formula we're going to use in this case is the formula speed is equals to 2 times distance over the time. And in this case, the reason as to why we are saying 2 is because this is echo method. So the sound is going to travel to the wall and then come back. Are we together? So once we have identified that, we need also to realize there is another method you can use. You can be able to use oscilloscope method. You can as well use two people standing different 100 meters apart. If you have one student on one side, another student on the other side, you are going to say one person to bang the pieces of wood together and the other person to stop the stopwatch immediately they hear the sound. So there are different approach you're going to use. It will depend how the question has been structured. So another possible question you can be seeing in your exam is whereby you are given an oscilloscope diagram like this, and we are told a microphone is connected to an oscilloscope and sound is detected by the microphone. The diagram shows the oscilloscope trace. So you have the y direction, 1 square is equals to 0.1 volts, that is the amplitude, and the x direction we have the time base, which is 5.0 milliseconds. Milliseconds is the same as 5 times 10 raised to power negative 3. So once you've identified that, we are going to look at how many boxes makes one complete cycle. So we are going to count the number of boxes that gives us a complete cycle, so that we can be able to work out the time period. So you can be able to see in our diagram that we have here, we can see that one cycle is after how many boxes? 1, 2, 3, 4. 4 boxes. So this is going to be 1 2 3 4, so it's going to be 5.0 milliseconds times 4, because 4 boxes is what we have in order to have a complete cycle. And in that case, this is going to translate to 20 milliseconds, and milliseconds to seconds, we're going to times 10 raised to the power negative 3, and that is going to translate to 0.02 seconds. Right, so we have the period. We are supposed to work out the frequency. We need to remember that the formula for frequency is equals to 1 over period, and that means we are going to use the time period that we have gotten here, which is going to be 50 hertz. 50 hertz as the frequency of this particular sound. So in the event they want you to work out speed, they must give you the wavelength, and then you will say speed wave equation V is equals to F lambda, and we can be able to work out the speed of sound from the oscilloscope using that formula. Once you have the amplitude, sorry, you have wavelength, you have the frequency, you can be able to say speed is frequency times lambda. Now, moving to cosmology and moving to astrophysics, that is astronomy, we shall look at HR diagrams. And HR diagram, we call them Hensprung-Russell diagrams, which usually show different stages of stars. And we have the main sequence, which is the middle part. We have the upper part, this is the main sequence, and we have the upper part, which is the red giants, and then we have the white dwarfs. These white dwarf guys here, these are the white dwarfs, and then up here we have the red supergiants. These are massive stars. So we are supposed to draw lines. D is representing the white dwarfs. D is representing the white dwarfs. So we are going to say also A is going to be the bright blue stars, and then we have B is going to be the red giants, and then C is going to be the main sequence, which are stars similar to the sun. And then we're supposed to describe what's meant by absolute magnitude, and we're going to say this is the brightness, or the measure of how bright stars will appear if they are placed at a standard distance from the earth, and that is usually 10 parsec, right? Another definition you need to understand is apparent brightness. Apparent brightness, how bright stars will appear, how bright stars appear from the earth. So some stars will appear brighter than others, but in that case you cannot be able to determine that is a brighter star than the other, because some stars will appear less bright because they are far, and some stars will be a bit bright if they are closer to us. So the best measure of brightness is the absolute brightness, and this is when stars are now assumed they are at a given standard distance from Earth, so you can be able to do the comparative analysis which star is brighter than others. And because brightness of star depends on the types of reaction that are taking inside, and also the size of those stars, how far or close they are to Earth, determines the brightness of stars. At this level also, I need to mention, whenever you are preparing, as you are preparing for this exam, you need to understand different life cycles of stars. Now, you need to understand that formation of stars begins when gravity pulls the gas and dust particles called nebulae together and compress them. So gas, dust and dust particles, nebulae, are pulled together due to gravity, and they are compressed. As they are compressed, temperature and pressure increases. When temperature and pressure is enough for fusion of hydrogen, then that star becomes a protostar. Now that is a young star. Now immediately the star starts generating its own heat from the internal structure, from the inner core, then it means there will be outward pressure and there will be inward pressure. When inward and outward pressure are balanced, the star now moves to second stage, which is called the main sequence. So in the main sequence, inward and outward forces are balanced, so the star is stable. That's where the sun is right now. And at the main sequence, fusion of a hydrogen and hydrogen is taking place. So the star will remain in that main sequence stage for billion and billion of years until all the hydrogen is used up. And when all the hydrogen is used up, the star now collapses due to its gravity, and then it gets compressed. It will run out of fuel. It will be compressed due to gravity, and then fusion of helium and helium begins, and then that star is going to expand, becomes very huge. Now it becomes a red giant. So in the red giant stage, the star is fusing helium and helium, right? Now in that process, when all the helium is used up, the star is going to run out of fuel. Then the star now will collapse again and cool down, because there is no fusion taking place. When all the helium is used up, it will cool down to become a white dwarf. So that is for those are the life stages for low mass stars, or stars with similar mass to the Earth, similar mass to the sun rather. So low mass stars and stars similar mass to the sun, they follow the first stage, protostar. They become main sequence, they become red giant, and then they cool down to become the white dwarfs. Those stars which are very, very massive, they have mass greater than that of the sun, they will become protostar. And then when all the forces are balanced, the inward and outward forces are balanced, they move to the next stage, which is called the main sequence. Now from the main sequence, when all the hydrogen is used up, this star will move to the next stage, which is the red supergiant. For massive star, they become red supergiant from the main sequence. And when all that star now will move to the next stage, which is called the supernova, which is the exploding star, which will explode, either to become a black hole if it was very, very massive, or it becomes a neutron star if it was just massive. So you need to understand different life stages for stars, basically for massive and less massive stars. So first, let's write down. I think I went out but of the area that we are focusing on, but I'm very sure questions will be asked around there. So you need to understand different stages of stars and how they differ, so that you can be able to earn all your marks. So moving down to the next part, we're going to focus on the topic of matter. Of course, we know that solids, liquid and gases have different characteristics, and these states of matter, the arrangement of the particles differs. So remember, this concept we learn also about the kinetic theory of matter, and we say that particles they are in a continuous vibration. They have particles vibrate, they have kinetic energy. So for gases, particles are much far apart and they move randomly. For liquids, they are closer. For solid, particles are fixed and arranged in regular patterns. So that's why you can see here we are supposed to identify different arrangements for liquids and solids. And you need to realize for liquids, the particles are a bit spaced, and they slide over each other. They have larger intermolecular spaces compared to solids. So you can see for solids, they are closely packed, and that is why solids, they usually have what we call a high density, because the particles are closely packed. There are many, yeah, and they vibrate in fixed position. Yeah, so basically if a question comes from that area, I believe you'll be in a position to answer it. you'll be in a position to write the arrangement. And here we are told that freezing temperature of gallium is 30 degrees and the final temperature of the solid is 20 degrees. So initially the temperature was 80 degrees Celsius. Freezing is 30 degrees. So how are you going to draw that diagram? The initial temperature was 80. It will cool down, it will lose the heat. Then when it reaches 30 degrees, temperature is going to remain constant. So we are going to identify that on the scale. We have 20, we have 40, we have 60, 180. So from 180, remember we are going to have freezing at 30. So we shall have a straight line like that. And then this is going to be horizontal, where now freezing is taking place. Once all the liquid has been frozen, now temperature of the liquid will start decreasing to 20 degrees Celsius. So basically that's what you are supposed to do in order to answer this particular question that was asked here. So in the event, if it's for heating, you have to also notice that when there's change of state, where we have the horizontal line, there's no temperature change at that given point. Yeah, so the next part is to calculate energy required to raise the temperature from 16 to 100 degrees Celsius. So we need to understand that quantity of heat, the amount of energy, is actually going to be mass times specific capacity times the temperature change. So M is the mass and C is the specific capacity. In the event you are asked to define the term specific heat capacity, you are going to say specific heat capacity is the amount of thermal energy required to raise the temperature of 1 degree Celsius of a substance specific capacity is the amount of thermal energy required to raise the temperature of 1 kg of a substance by 1 degree Celsius. Specific heat capacity is the amount of thermal energy required to raise the temperature of 1 kg of a substance by 1 degree Celsius. So in the event that question is asked, I'm very sure once you've attended a class of Proflan YouTube channel, you'll be in a position to answer that. So the data we are going to work out here is the difference between the temperature. It was initially 16 to 100. The temperature change here is 84 degrees Celsius. And if you work it out, you are going to get your answer equivalent to what? 15,860 joules, and we shall transfer our answer here to make the examiner happy. The diagram shows the temperature time graph for the sample of water, and we are supposed to identify the time when boiling is taking place, and then we can see here is between these points, and also this is 7.4. so the time is 7.4 minus 3, which is 4.4 minutes. And of course you are using this level. This is where there is a change of state, and of course we are just reading these values here so that we can be able to get our answer in that case. Yeah, so there's no temperature change in that case because all the energy supplied is used to break the forces of attraction, yeah, to break the molecules so that they can be able to evaporate. Yeah, so right, so give reason why the liquid water should be stirred during heating. This is for uniform distribution of heat throughout the entire liquid, so that and to ensure that the whole liquid, the entire liquid, is having the same temperature. So we are going to say for uniform distribution of heat within the liquid. That's why whenever maybe you are doing this particular experiment, you have to stir the content. Describe the change of arrangement of motion and the motion of molecules in liquid and in steam. Steam is gas. So basically we are going to describe the arrangement of molecules of molecules in liquids and gas. For liquids, they are close and they slide over each other. for gas, they are much further apart, and they are moving randomly in high speed. So basically that's how you are going to answer such kind of questions. So for water become gas, when water become gas, the molecules are widely spaced, they move more randomly in straight lines, and they move at higher speed. So if a question comes like that, I believe we have tried to answer as many questions as possible for you to be able to answer a question on that. So for transformers, you can also be given a diagram on transformer like this one that we are having here, and then we are supposed to work out the power output, power input, voltage that is produced, which is the V out. And then let's see, the power of the transformer is the input power is 16 watts. Here we are told input power is 16 watts. And also you need to remember that power is voltage, or current times voltage. And then we are told the transformer is used for 2.5 hours. Calculate the energy transferred. Power is the rate of transferring energy, right? So if we want to calculate the amount of energy transferred, it will be power times time, isn't it? Then we can be able to say it's 16 times 2.5, but the 2.5 hours has to be converted to seconds so that we can be able to get our answer in that particular case. So we shall have 144,000 joules of energy that is being transferred. Explain how a transformer works, and already have mentioned here that when alternating, and in this case now, because we had explained on a step down transformer, let me now explain this using a step up transformer. And the fact is, a step up transformer is used to increase voltage, and also it has more turns in the secondary coil than in the primary coil. So we're going to say when alternating current is going to flow in the primary coil, then magnetic fields, which are constantly changing size and direction, are created in the primary coil. When these magnetic fields created in the primary coil cut across the secondary coil, they are going to create an induced EMF. There will be an induced EMF through electromagnetic induction, right? And you can see here we're having a ion core. A soft ion core is basically used because it can easily be magnetized and demagnetized, because it's a soft magnetic material which can be easily magnetized and demagnetized in that case. Did we mention that since we have more coils in the secondary coil, or we have more turns in the secondary coil, there will be a larger induced voltage in the secondary coil, thus a step up transformer. Yeah, so don't forget that transformers don't work with steady direct current, because they don't create magnetic fields which are constantly changing size and direction. All right, so moving further, you are asked, state how the primary coil of the transformer can be changed to increase the output voltage. If you want to increase the output voltage, just reduce the number of turns in the primary coil, or increase the number of turns in the secondary coil, or increase the input voltage. So that's the way that can be done. Basically, this one was focusing on primary coil, so we shall talk of that. Moving to this question, this is actually Doppler effect, and you need to understand that Doppler effect is the change of wavelength or frequency of a wave due to relative motion between the source and the observer. Now, sometimes you've had a sound of a car approaching. You will hear sound of that car approaching. Will be hearing sound of high pitch than when it has passed you. Yeah, because when the car is approaching, the sound waves, the wave fronts will be compressed. When they are reaching your ear, they are very, very close. Those wave fronts of sound, they are very, very close when the cars are approaching. So you are going to perceive sound of high frequency, and when the cars left, the wavefront spread out, and then you are going to detect sound of low frequency. So in this case, we are supposed to talk about redshift, and redshift is the phenomenon that occurs when the light observed from distant galaxies, they display, when that light is measured, the wavelength of light from stars is measured, has a longer wavelength than they usually have. So the reason as to why is because that is the case is because stars, the galaxies are receding, they're moving away. So the observed wavelength is usually longer, right? So that is now a blue shift. That is a blue shift. Rather, that's a red shift. I don't know why I'm just red shift. All the galaxy displays the red shift because the wavelength of the light they emit is longer than it is because those stars are moving relative to the observer on Earth. So all galaxies, they display a red shift because the universe is expanding and the galaxies are moving away. So there's we are asked to identify the region where the star will be. Because the star is rotating in that orbit, we're supposed to identify where the star will be showing maximum wavelength. It will be showing maximum wavelength at point X when it's going in that particular direction away from the observer. Yeah, and at point A, the star will display, when it's going this way, it will display a blue shift because it will be approaching the Earth. So the wave that is observed from Earth will be shorter because the star in the other point A will be approaching the Earth. Yeah, so here the star will display maximum wavelength as it's moving away. Yeah. Now we are supposed to calculate the speed of the galaxy. We're going to use this formula, change in wavelength over wavelength on Earth in the lab, of speed of the galaxy over the speed of light. So you can see we are told that light received on Earth from the distant galaxy, the longest wavelength of light arriving Earth from the galaxy is 561 nanometer. The lamp on Earth produces the same light. In the lab on Earth, the same light is 550, but the light that's observed from that galaxy is 561. So you can see the wavelength is longer. So this is now the red shift that we were talking about. The observed wavelength is longer than the same light that is being produced on that particular star. So probably what we are saying here is that star is producing wavelength of 550, but since it's moving relative to the observer on Earth, we are going to measure a larger wavelength. So we need to work out the change in wavelength, the difference in the wavelengths. So we shall say 561 minus 550 over 550. The lambda that you are using down here should be the wavelength on Earth, in the lab, of the light on the lamp, or of the light on the lab, and C is the speed of light. Then V is going to be the speed of the galaxy. So we shall say this is going to be 561 minus 550 over 550 is equals to V over 3 times 10 raised to the power 8. Then we make V the subject of the formula. In this case, we are going to have 11 over 550 times 3 times 10 raised to the power 8. And if you work it out, you are going to get the speed of the galaxy being equivalent to 6 times 10 raised to the power 6 meters per second. That's the speed at which this galaxy is moving away. And this blue shift that is being observed is one of the evidence of Big Bang theory that the universe is still expanding, because some galaxies, all the galaxies actually that have been studied, are displaying a redshift, because since the universe is expanding, the parts and the galaxies are moving away from each other. All right, so moving further, we're supposed to describe the difference between neutral sulfur particles and positively charged sulfur particles. Neutral sulfur particles, a neutral atom has equal number of electrons and protons, but a charged one has imbalance. So in this case, neutral has equal number of protons and neutrons, while positive charged has less electrons. So when an atom has less electrons, or when electrons have been transferred or have been lost, that atom becomes positively charged. So the reason as to why an electron P is going to be accelerated is because plate P is negatively charged, so it's going to repel that electron, and since plate the other plate is positively charged, is going to attract it. So that electron is going to have a resultant force to the right, hence it's going to experience an acceleration. So sulfur particles are attracted to the negative plate. The sulfur particles are attracted to the negative plate, and they are repelled by the other plate, so they are going to be accelerating to the right because there is a resultant force. All right, so in this case is into the page, so you can be able to see that question. The tube has the radius of 1.1 kilometers, and the sulfur particles has an orbital speed 2.9 times 10 raised power 8, and you are supposed to calculate the orbital period, and you need to realize that this is like orbital speed of stars. We are going to say is v is equals to 2 pi r over t. So this is orbital speed of planets around stars. So you can be able to substitute what we have provided, so that we can be able to make t subject of the formula in order to work it out, and our answer becomes what? The orbital period. If you put it in the calculator, our answer becomes 2.838 times 10 raised power negative 5 seconds. Now the next area is about momentum. You need to understand the formula you can be able to use to work out momentum. Also, you need to understand how you can be able to calculate the mass, because if you are given momentum and you are given the velocity, you can make m the subject of the formula in order to work out the mass, in this case, which is approximately 80 kgs. Moving down, we are supposed to calculate the time taken. So this is Newton's second law of motion, that force is equal to the rate of change of momentum. Now the dummy is brought to rest. Impulse is force times time, and impulse is equals to change in momentum. Initially the momentum was given, so let's write the formula for impulse is equal to change in momentum. So ft is equals to change in momentum. P is momentum in that case. So we are told that the force is 15k newtons, which is 15,000 newtons times time. Change in momentum will be 1100 minus 0, because if it was brought to rest, the final momentum will be 0. So change in momentum will be 1100, which we had worked out, minus 0, and then we divide by 15,000. That is going to translate to a total of 0.073 seconds time. Yeah. Using airbags. Even cars are fitted with airbags. The reason as why that is done is to reduce the injury. And how does it reduce the injury? You realize that airbags and soft materials, they increase the time of impact. And when you increase the time of collision, you are going to reduce the amount of force this is going to be experienced. So airbag increases time of collision. It increases the time of collision or time of impact, which reduces the rate of change of momentum, because we said force is equals to change in momentum over time. So if you have longer time, if you have more time, you are going to reduce. If you increase the time, you are going to reduce the amount of force experienced to the person who hits the dashboard. The dashboard. Remember, in cars we have airbags. Instead of the person hitting the dashboard, there is airbag which is going to decelerate the person. So the time of collision is increased, and when the time of collision is increased, the impact is going to be less, and this is going to make the person to survive. So this is the remaining part. Calculate the main force. Now we are told the cricket player hits a ball with a bat. Before the ball is hit, it's moving to the left, and the momentum is 4.2. And when it's hit, it moved to the left. Yeah, it was initially moving. When it was hit, when it was moving to the left, it was having a momentum of 4.2. When it's hit, it moves to the right at 6.7. So remember, to the left we can assign negative, because momentum is a vector quantity, so it has direction. So to the left we can assign negative, to the right positive. Then we have the time to be 0.012 for the change of momentum. Then we can be able to say Ft is equal to change in momentum. In this case, we are having this moving this direction and this one moving the other side. So you can say Ft is equal to change in momentum. And our change in momentum in this case is going to be equals to 6.7 minus 4.2. And if you work out the difference here, we are going to say the difference is going to be 10.9 over the time, which is 0.012 seconds, so that we can be able to work and get our force equivalent to, we work out the force, we're going to get 908 newtons. And this 908 newtons will be to the right. State the magnitude and direction of the mean force the ball exerts on the bat. It will be the same for every action force. There is equal reaction, which is going to be 908 as well, but the direction is going to be to the left. So that's one. I think that one is much okay. And then we are told the cricket player wears padded protective equipment. The padded protective equipment, they have soft materials like blankets inside there, some cushioning materials, and the purpose of those cushioning materials are going to increase. They're going to increase the time of impact, the time of collision. So you need to realize that there is a change in momentum when the ball hits the player, and now these cushioning padded materials are going to increase the time of impact, and this decreases the rate of change of momentum. And when the rate of change of momentum is decreased, the force experienced decreases. The force experienced decreases. The force experienced decreases. The next part that you really, another area that you must focus on to ensure that you are in a position is about energy resources. You need to also know different types of energy resources in renewable and non-renewable energy resources. We're going to say renewable energy resources are resources which cannot be depleted. However much you can be able to use them, you cannot use. They can never run out. You can never finish them. And in this case, we can talk of solar. We can talk of wind energy, we can talk of geothermal. These are some examples of non-renewable energy resources. They are there to be used, right? And you need also to understand different advantages of different resources and disadvantages. So for instance, when we are talking about oil, we talk of coal. They have advantages and also they have disadvantages. An example of disadvantages of coal and oil is that they produce greenhouse gases. They produce CO2, which is detrimental to the environment. Also, they are non-renewable. They are non-renewable, isn't it? Yeah, they are renewable. They are non-renewable. Yeah. So non-renewable resources such as coal, once used up, they cannot be non-renewable. Once used up, they cannot be replaced, isn't it? But renewable, they can never run out. Sun, can you ever finish the energy from the sun? Wind, you will be able to use it forever. Advantages of renewable energy resources: they don't produce greenhouse gases, they don't contribute to global warming, they don't contribute to acid rain, and so on. Now, so hydropower station is an example also of energy here, which make use of the potential energy of water held in a high level point, and when that water runs through the tunnel, the potential energy is converted to kinetic energy, which runs the turbines, and the turbine rotates the generator, which produces electricity through electromagnetic induction. So basically that is it. So we are supposed to describe the energy transfer that involves the hydroelectric power. So we have GPE here, and when the water runs through the tube, we are going to have kinetic energy, and that kinetic energy of the water is going to run the turbines, and then the electricity is generated. So if you are supposed to talk about that, we're going to say in the upper lake, water has high gravitational potential energy, and when that water is released, the gravitational potential energy is converted to kinetic energy as the water flows down. So it's converted to kinetic energy, and that kinetic energy is the one that is going to run or is going to rotate the turbines. Yeah, and once the turbines are rotated, which will make the what we call the generator to rotate, and then electricity is produced, which is transferred through the cables from the power station to the people who are maybe very far. Yeah, so basically that's how we shall explain, that's what we shall put down in order to earn our mark. Right, so I can see we are almost coming to the end of this particular paper. What's the next part? Give the one advantage of using hydroelectric power station, because they can be able to meet the demands, the rising demand of electricity. Yeah, they don't contribute to global warming, they don't contribute to acid rain. Yeah, so disadvantage is that they require large capital, and also they need a large area to be flooded in order to have it. So there is also comparison between wind energy. Of course, wind energy is used. How is wind used to generate electricity? Wind is used whereby when wind blows, it makes the turbines to rotate, and when the turbine rotates, inside the turbine we have the generator, which generates electricity through electromagnetic induction, because we have a coil, we have a magnet there. So but the disadvantage of wind energy is that it's not reliable, and it cannot produce enough electricity. The electricity keeps on fluctuating depending on the amount of wind. Yeah, and the disadvantage also, we can talk of produces a lot of sound, noise pollution, and also it can kill birds. State what's meant by astronomical term galaxy. Galaxy is a collection of billions of stars, and collection of large collection of billions of galaxies, actually the universe. But the solar system is a star and planets and satellites there. Yeah, so this one I think we've already done it in order to work out the speed of a galaxy. And yeah, so if you find that you have less speed than that of you are supposed to compare the motion of galaxy A and B. A is moving towards the Earth. If the wavelength is short, it means this galaxy is moving closer to us. If the wavelength is long, it means that the galaxy is moving away. And if the speed, if the wavelength is also long, it means the galaxy is moving at a higher speed. Yeah, so we can say galaxy A is moving toward the Earth, B is moving away from the Earth, B is moving faster than galaxy A. Working out the speed of the galaxy already we have said, and we have seen how we can be able to use this kind of formula, and I believe this one is just a walk in the park. In the event you are going to see a question related to that, which is 6.2 times 10 raised to power 5 meters per second. Well, so how materials are charged? Materials are charged due to friction, and you need to understand also electrical type of formulas. In this case, yeah, plastic is an insulator, so when materials are wrapped, they charge. Insulators, the charge stick on the surface, but for conductors, that charge is going to be conducted away. So that's why it's difficult to charge a metal, because the moment it charged, the charge is going to be transferred or conducted to the ground. Yeah. Right. Then also you need to remember the formula for energy. Energy is equals to work. Energy is equals to charge times voltage, and if you use that particular formula, and then we are going to have 8.3 times 10 raised to power 7. Yeah, different ways you can be able to determine whether the sponge is having a charge is either by using repulsion. You're going to use repulsion, or you're going to use attraction. So if you bring another charged sponge and check if there will be attraction or if there is going to be repulsion. So up to that particular point, we are going to say I wish you the best, and I wish you the best of luck in your coming exam, because we shall stop here, guys. If you have subscribed to, you have not subscribed, consider subscribing, so that in time I'm going to do more tutorials, you'll be notified. See you the next video. Don't forget to check the Patreon page, where I usually upload the PDF so that you can be able to have it. See you. Good luck.